Okay, this is the first part of lesson 2. It's piecewise functions. So for this one, you're going to look at pieces of functions, and it depends on the different input values that you would be using. So for example, on number 1, here are my two equations, x squared minus 1, if your x value is less than negative 2, or I have 5x plus 3 if x is greater than or equal to negative 2. So depending on your input values will depend on which equation you will use. I'm going to start by looking at negative. Is negative 5 less than negative 2, or is it greater than or equal to negative 2? Negative 5 is less than that, so I'm going to plug it into the x squared minus 1 equation and then simplify. So I'm going to plug in negative 5 anywhere I see an x. Negative 5 squared is 25, and 25 minus 1 is 24. Now for the next one, I'm going to look at negative 2. Negative 2 cannot be less than negative 2, but negative 2 can be equal to negative 2. So that means I'm going to plug it into the second equation of x plus 3. I'll do 5 times negative 2 plus 3. Negative 10 plus 3 is negative 7. Last one, plug in 7. 7 is not less than negative 2, but it is greater than or equal to that. So it means I'm going to plug it into the 5x plus 3. 5 times 7 plus 3. 35 plus 3, which is 38. Same thing down here. 2 is not less than negative 4. It's not between negative 4 and 1. It is greater than 1. So that means I'm going to plug it into my 2x cubed plus 9. 2 times 2 cubed plus 9 is going to give me an answer of 25. 2 cubed is 8 times 2 is 16 plus 9 is how I get 25. Negative 1 is between negative 4 and 1. So I'm going to plug it into negative x minus 1. Negative 1 and a negative, so that's negative, it'll stay there, plug in the negative 1. Negative times a negative is a positive, and 1 minus 1 is 0. And then negative 6 is less than negative 4, so I'm going to plug it into this one. That'll be 1/2 times negative 6 plus 3. Half of negative 6 is negative 3, so you also get 0. Okay, so here comes the fun part. We're going to be graphing. You will need a calculator. You will need a ruler, and then you also need to be able to graph. So we need to remember y equals mx plus b, which is slope-intercept form. M is your slope, b is your y-intercept, and this is where your graph is going to start. So you also need to remember that if I have less than or equal to, greater than or equal to, we're going to have a closed dot. If I just have less than or greater than, that means it'd be an open dot. Okay, so there's a couple ways that you can do this. I'm going to do it in pencil to start, and then we can kind of go from there. So the first thing that we're going to do is I'm going to graph this line right here. So this line is f of x equals x. That means for this one, my slope is 1 and my y-intercept is 0. So all I'm going to do is plot my points, but do not connect them because I will not need all of them, and I'll explain why in a second. So I'm going to start at 0, and then my slope is 1, meaning I'm going to go up 1 over 1, or down 1 over 1. Some of the lines are kind of hard to see, but here's what my line would look like, give or take. Okay, so then from here, I don't want all of these values. I strictly want numbers that are less than or equal to negative 3. So it means I'm going to go to negative 3, which should be down here. Yeah, it should be at negative 3. Pretend my line was perfect, but it's hard to see. Okay, better. So it means I'm going to go to x is negative 3. So 1, 2, 3. That means this is the point that I want. And I want value less than or equal to that, which means I actually only want the numbers going this direction. And then I don't need any of these ones because I only want numbers that are less than or equal to negative 3. So looking at your next one. Okay, so this one, I don't think I have an erasable pen. Okay, so for this one, this will be line number 2. My m is negative 2 and my b is equal to 1. So I'm going to go up to 1. And then my slope is negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1. Okay, and then I'm going to go the opposite direction. I'm going to go up 2 over 1. Oops, I could count today, that would be really helpful. Okay. Now the difference of this one is I want x values that are greater than -3. So I'm going to find x is -3. And this is the point I'm looking at. Since it's greater than, it means it needs to be an open dot. And I want the values that are greater than -3, which means I want all the values that are going to the right. So it means I'm going to connect all of these together. So here's what my graph is going to look like. This is line 1, this would be line 2. The reason I'm able to figure out where they're starting is because of these values right here. Line 1 wants values that are less than -3, line 2 numbers that are greater than -3. So what we're trying to figure out for your domain is I need to figure out if we will include all x values. If I go from left to right, so from left to right, I go to -3, but I include -3. Okay, and then if I look here, if I were to go all the way across, I'm going to hit an x value at every single spot. Or if I do this vertically, hit one at -10, -9, -8, -7, -6, -4, -3, -3, -2, -1, 0. I'm going to hit an x value every single time that I bring a ruler across. So that means main is going to be all real numbers. Okay, but now for my y values, I have an arrow pointing down, which means I'll hit all negative y values. But if I go up forever, you're going to notice that the highest y value I go is this point right here, which is, if I count, is 1, 2, 3, 4, 5, 6, 7. So in this case, I want all y values that are less than 7. The reason I don't include 7 is because this is an open dot. All right, let's try this again. So for this one, for line 1, my slope is -3. And my b is -7. So 1, 2, 3, 4, 5, 6, 7. My slope is -3, so I'm going to go down 3 to the right 1, but since I don't, it's really bugging me. So it means I'm going to go up 3 to the left 1. Okay, but I want values that are less than -1. So I'm going to go to find where x is -1. That means I'm looking at this point right here. I want numbers that are less than that, but not equal to. So that means I need to change this to an open dot. And I want numbers that are less than that, which means I want numbers to the left. So I'm going to connect all points to the left of -1. So this is going to represent line 1. Line 2, I don't have a slope. So when I have y equals to a number, it means it's a horizontal line. So I'm just going to go to -5. 1, 2, 3, 4, 5. Draw my line. And here's what my line should look like. However, I only want y values that are greater than or equal to -1. So I actually don't want this left side. I want from here with a closed dot over. I made this circle a little too big. Okay. Domain, I go from left to right forever, so my domain will be all real numbers. But for my range, 5 is a straight line. There's nothing below it. But there's also a gap between this closed dot and that open dot. So for my range, I want y values that equal -5. And, so this U means and, or union, I want y values that are greater than -4. Okay, let's try. Okay, I'm going to skip this next one because I want to do it when there's 3. Oh, I want to do this one. No, I'm going to skip it. We'll do 6. Okay, so number 6 has 3 different ones, so you just need to be able to do both lines. Okay, so the first one is I want -1. Okay, so I'm going to go to -1, and technically, okay, so here's -1, but I only want x values that are less than or equal to -5, so I'm going to go to -5, so 1, 2, 3, 4, 5. It's less than or equal to, which means I want a closed dot, and I want x values that are less than that, so I'm going to go to the left. So this is line 1. Kind of hard to see. Let me draw it a little bit darker. So here's line 1. Okay, second one says I want the line with slope of -1 and my b is at -3. So let's go to -3. 1, 2, 3. And then I want to go down 1 over 1. Okay, but I only want this to happen at -5. So I'm going to find -5. 1, 2, 3. But at this point, I only want to be less or greater than that technically, so this should be an open dot. And then I want to stop at x equals 1, which would be this point right here. So I'm also going to change this to an open dot. So I'm only going to connect the points between these two open dots because I only want x values that go between -5 and +1. So then technically I don't need these points right here. And last but not least, I want y values of 6. So 1, 2, 3, 4, 5, 6. But I only want to include values greater than or equal to 1. I think I miscounted. 1, 2, 3, 4, 6. And I only want to start at 1. So I'm going to go to 1 right here. It's a closed dot, and I want numbers to the right of that. Okay, so that's line 1, this is line 2, and then this is line 3. So for your domain, we need to see if we have a continuous set of numbers. I had all the numbers to the left. I stopped here at -5, but -5 has a closed dot, so we're good. It means I would include from -5, but 1 is an open dot, but 1 is a closed dot up here, which means that technically it's a closed dot. So if I go from left to right forever, you will hit all possible x values. So my range is all real numbers. Or my domain, excuse me. For my range, this is where it's a little bit different. If I go from down here, the lowest y value that I hit right here is at -4. And then I go all the way up, and then my graph stops right here too. So I don't have to stop here because my line continues on. But I go from -4 all the way up to 2 without an issue. So that's the first part of my range. So -4 is less than y, which is less than 2. They're not equal to because these are open dots. And then I have this gap until I reach this line right here, and that line is at y equals 6. That's your final answer. Okay, we're going to do one more just so I can show you when there is a gap, and then we'll go from here. Okay, so if we look at this first one, we know my slope is -3, my b is at 0, so we'll go to 0, and then I'm down 3 over 1, and I want x values that are less than 0. So that means I only want to include the numbers that are to the left. So I'm going to open dot right here, but I only want these values. So that means I only want the ones that are going up because these are the numbers that are less than 0. So I can get rid of these points. Next one, my slope is at -1/2. My b is at -1. I'm going to go down 1 to the right 2. And I only want this between 0 and 6. 0 I'm going to include, but at 6, so 1, 2, 3, 4, 5, 6. I'm off somewhere because I'm missing lines, but 1, 2, 3, 4, 5, 6. Oh, it's right here. So it's going to be an open dot because I want numbers that are less than 6. So from here to here. And then not least at -7. 1, 2, 3, 4, 5, 6, 7. And then I want to go up 101. So we are going to start right here, the open dot, and then I go up forever. Okay, here's my graph. For my domain from left to right, I hit all the numbers to the left. I have a closed dot at 0, so we're good. But when I go to the right, I have an open dot at both of these. So that means I would not include that number. So for the domain, I want all x values besides +6 because that's where I have my open dot at both of these. This one at 0 has a closed dot and open dot, so we're good. But over here I have 2 open dots, which means it does not get enclosed, so you cannot equal that number. For my range, let's see, I go from my lowest value is -4, and then I hit every number that's higher than that. So my range, or y values, that are greater than -4. All right, so try these out, and I will definitely hold a session in case you have questions.